Hi, welcome. Today's lesson is on boiling and freezing and the heat involved in those processes. So in the evening, I put some water on the stove to boil, and I'm thinking to myself, I wonder how much heat is being used to boil this water. So I get out my trusty thermometer, I put it in the pot, and I see that I have a reading of 100 degrees Celsius. So I wait a few minutes thinking I might need a change in temperature to figure out how much heat is being used. And I put the thermometer in again and it reads 100 degrees. So I'm thinking, well, that can't be. So I wait another 5 minutes. The water is still boiling. I put my thermometer back in the water. It is still 100 degrees. No temperature change. And the boiling point of water happens to be 100 degrees. So then I think, if there's no change in temperature, does that mean there's no heat needed to boil water? Because I remember the equation Q equals mc delta T, and if delta T, if there is no change in temperature, does that mean Q is 0? Well, mathematically, that looks to be correct. But then I think to myself, but if I take the pot off the stove and remove it from the heat source, it doesn't continue to boil, it stops boiling. So the Q equals mc delta T does not work when something is boiling, or the opposite, which is condensing, or if it's melting, which the opposite is freezing, because during those changes of state from a liquid to a gas, or a gas to a liquid, or a solid to a liquid, and a liquid to a solid, the temperature remains constant. There is no change in temperature. So if I want to calculate the amount of energy needed to heat my pot of boiling water, I can't use Q equals mc delta T because there is no change in temperature. So I need a new equation, or I need some new terms to help me solve that. And one of those new terms that you're going to need is called the heat of vaporization. So take some notes if you're not already doing so, and you can pause the video. And the heat of vaporization is defined as the energy needed to vaporize, which we also call boil, is the energy needed to boil something. And that's given in like joules per gram or joules per mole. And the symbol is a triangle, which stands for delta, H, and a little v for vaporization. And for water, that happens to be 2,260 joules per gram is the heat needed to boil water at 100 degrees Celsius. So I need a new equation to go with my new term. And so now I have Q doesn't equal mc delta T, Q equals N delta H, or M delta H. And you might say to Ms. Backus, why are there two equations for this? Well, you have to use common sense and unit analysis to figure out which one it is. And remember that N stands for moles. That was PV equals nRT. We know N stands for moles. And here M stands for mass. So which equation do I use? Well, that depends on the units given in your delta H value. Delta H values are constant, and you can look them up on the internet, but sometimes they're given in different units. So if you look up a delta H value and it's given to you in joules per gram or kilojoules per gram, then to find the joules, you're going to need to multiply by grams so that the grams cancel and you're left with joules, which is the energy unit for heat. But if you look up a delta H value and they don't give it to you in joules per gram, they give it to you in joules per mole or kilojoules per mole, then multiplying by the grams will not give you the answer. You have to multiply by moles. And so when you're doing these problems, do remember to look at the units. So here's an example of a problem you may come across. Let's go back to me heating the boiling water on the stove. Let's say my little pot contains just 100 grams of water, and it's at 100 degrees Celsius. The heat of vaporization, as I said, was 2,260 joules per gram. So now I'm going to use this equation because I'm going to need to multiply by the mass to get rid of those grams. So I plug in my values. I have 100 grams times 2,260 joules per gram. The grams cancel, and I'm left with 226,000 joules. Well, that's a pretty big number. So I may want to convert that to kilojoules, and if you do that, then that's 226 kilojoules. Now the same idea is for melting. If you take some ice and measure the temperature and it's starting to melt, it will be 0 degrees Celsius. It will continue to be 0 degrees Celsius until all the ice has melted away. So how do I calculate the heat needed to melt something? Well, once again, I can't use Q equals mc delta T because there's no change in temperature. So instead, I need a heat of fusion, similar to heat of vaporization, and it's defined as the energy needed to melt or the energy given off when it freezes, same amount but opposite direction. And that is given the symbol triangle delta H of fusion. And for water, the heat of fusion is 335 joules per gram. So I'm going to use the same equation as I did for boiling, except it has a little subscript F for delta H subscript F. So here are my two equations, and they're based on whether I need to cancel moles or whether I need to cancel grams. And I just need to look at the units that are given in the delta H value that I'm given from some reference source. So let's try an example. How much energy is needed to melt 50 grams of ice at 0 degrees Celsius? And the heat of fusion is 335 joules per gram. So I use my equation Q equals m delta H. And why m? Because the delta H here is given to me in grams and the units have to cancel. So 50 grams times 335 joules per gram gives me 16,750 joules, but that's too many sig figs, so I just need 3, so 16,800 joules. And such a big number, we should convert that to kilojoules. So that happens to be 16.8 kilojoules. So there you have it. How do you calculate heat when something is boiling or melting or freezing or condensing? When it changes state from solid to liquid or liquid to gas, you can't use Q equals mc delta T. You have to use these new equations. So thanks for listening. See you in class.